Okay, so today we're talking about volumes of cross sections, and so this first page is just a page of formulas that you may need to know at some point. Some of these are given to you, but the easier ones are usually not given to you. All right, so we're going to start on this page right here, and we're going to start off by looking at this first picture here. And so basically what happens in a cross section is you slice your solid, okay, into an infinite number of the very thin cross sections. The area of the cross section depends upon what shape the cross sectional piece forms, and then we're going to sum all of the cross sections together using integration, and integration is just simply an infinite sum. So basically what we've got here is if you look at this first one here, it says all examples are using the same base, and our base is given by x squared plus y squared equals 9. So that's an equation for a circle, okay? And so that's why we've got the circle down here, and it basically says what is the volume of the solid with a base given by this equation, x squared plus y squared equals 9, and with cross sections perpendicular to the x-axis that are squares. So if you look to the right side over here, you can see this little picture in red and yellow and blue here. So you can see the part of the circle in blue here, and basically what's happened is we're building cross sections out of this that are squares. And so as you come up the side of the square over here, okay, you can see the height of the square and the width of the square. And if you do that, an infinite number of little thin squares, you would make this shape that you see up here, and you can see as the circle gets wider, the squares get wider. That means their height gets higher, and so on and so forth. So this actually builds what we call a solid here. And so we want our cross sections to be squares on this particular solid. So what we're going to do is we're going to take, and I'm just going to draw one square on here so you can see what we're looking at here, but our squares would look something like this. So if we were to come across the base here, oops, let me take that off, let me try that again. So if we were to come across the base here and we were to build a square out of this, okay, so the height on this is a little bit funky to draw here, so I'm just going to do my best here. So if we were to draw a square, it would look, something along these lines, okay, and that square would be sitting perpendicular to the base, just like it does on the right hand side of our picture here. And so what we need to do is we want to be able to figure out what is the area of that square. And so we know that the area of a square is simply s squared, or side squared. But then we need to know what s is. We need to know the length of one of these sides right here. And so the length of that side is given by the part of the function here, the distance from one side of the circle to the other. We've been talking about that in terms of upper minus lower. Okay? So the height of this square is going to be the upper part of the function minus the lower part of the function, okay, and that's what happens right up here. Our upper function, this is upper and this is lower. That's going to be the base of our square, and it's also going to be the height of our square. All right, so in order to do that, we need to get this function in terms of y. So we're going to start off by subtracting x squared on both sides here. We have y squared equals 9 minus x squared. If we square root both sides, we get y equals positive and negative square root of 9 minus x squared. So the top of our function, we can say that the upper part of our function above the x-axis, so u is going to equal a positive square root of 9 minus x squared. And the lower part of our function is going to equal the negative square root of 9 minus x squared. So when I go to look at the height and the base of this rectangle, okay, so when we talk about, you can talk about it as base or height, it doesn't really matter. But the base of this rectangle here is the upper minus the lower, okay? So I'm gonna do a little bit of highlighting here if I can. So this guy right here in purple now, okay, that is going to be the, again, the height or the base, it doesn't matter. So height equals the upper minus the lower. So we have the square root of 9 minus x squared minus the lower, which is negative square root of 9 minus x squared. So the height is equal to, if you change these guys to plus, a square root plus a square root is just 2 of those. So it's 2 times the square root of 9 minus x squared. Okay? That height, or whatever you want to call it, is essentially our s in our square here. Okay? So s is equal to, the side of the square is equal to 2 times the square root of 9 minus x squared. All right? And so what we want to do is we want to look at the volume of this thing. Okay? And so to do that, we need to take the integral. And again, you can see all these little, squares on the side of the page over here on this colored picture here. And essentially, we want to add up the area of all those squares and figure out what the volume is of this cross section. Okay? So we're going to take the integral, and we need to go from -3 to 3, and the reason I know that is because my picture up here shows the circle going from -3 to 3. That's the radius of our circle, is 3. And we're going to do the integral of a of x. Okay, so in the picture up top, a of x is the area of whatever shape it is that you're dealing with. Our shape in this case is a square, so it would be s squared. Okay, so we're going to do, and actually just so you can see this, I'm going to do this, s squared, and I'm going to do dx. So our s in this case is -3 to 3 of 2 times the square root of 9 minus x squared, and then we need to square that whole thing dx. Okay, so if we could probably do this one by hand because the squaring on there is probably not a big deal, but we're going to go ahead and pull out the calculator and see what the calculator spits out here. All right, get a little more practice on that. So we're going to pop that in. We'll go ahead and clear this out, hit our math 9 again here. We're going from -3 to 3. And then our integral is, we need some parentheses in here. So we're going to do 2 times the square root of 9 minus x squared. And we're going to get out of that square root and close up our parentheses and square that. And then dx. All right, so if we pop all that in there, we're going to end up with a volume of 144. Okay, so what we've just found here, let me go back to my full screen here. What we've just found is that this is going to equal 144, and this is the volume of this shape here. Okay, so we're integrating an infinite number of squares to find the volume of that particular shape. Okay, now if you look at the same base, we're talking about the same base, a circle here, but this time it says what is the volume of the solid with the base, so we still have the same circle with cross sections perpendicular to the x-axis that are rectangles of a height 5. So instead of a square this time, we just have a rectangle. So it's going to come across just like it did before, but this time it's a rectangle with a height of 5. So it's not going to go up maybe nearly as high, or maybe it's going to go a little bit higher, but I just know it's going to be slightly different, so I'm going to try and draw it slightly different from the last one. The height's 5, but I still have the upper minus the lower portion. I still have the same base here. Okay, so my upper minus my lower is still going to be the upper being the square root of 9 minus x squared, the lower being the negative square root of 9 minus x squared. So that means again that the height, that the base on this guy, I called it height last time, but base equals the square root of 9 minus x squared minus the other square root of negative 9 minus x squared. So that gives us the base, just like last time, of 2 times 9 minus x squared. Now, if I look at the area of a rectangle, the area of a rectangle is simply base times height. We were told that the height was 5. We found the base earlier to be 2 times the square root of 9 minus x squared. And so what we want to integrate here is, this time we're going to integrate from negative 3 to 3. Same limits here. But this time we're going to do base times height. So we're going to do 5 times 2 square root 9 minus x squared dx. All right, and again, we would need to use the calculator to do that. I would encourage you to turn off the video and pop this in your calculator, and you should come up with 141.372 for that one. Okay. The third example here uses the same base, so we have a circle base here, but this time our cross sections are again perpendicular to the x-axis that are equilateral triangles. So you'll notice again, I'm going to draw the base. Okay, my base is still upper minus lower, which is the same base. But this time it's an equilateral triangle, so that means that all 3 sides are the same. So I'll try and draw this with all 3 sides that are the same. And so the area of the triangle is, and this formula was on the very first page, root 3 over 4 times side squared. All right, where again my side, okay, all 3 sides are the same, so the side here is going to be 2 square root 9 minus x squared. So 2 times the square root of 9 minus x squared, and then I just need to pop that into my integral. So we're going to be taking the integral from negative 3 to 3 of root 3 over 4 times the side squared. So actually I should do some parentheses here since we're going to square. This is 2 square root of 9 minus x squared, and that section is being squared. And again, this is a calculator problem. I would encourage you to take out your calculator and try this again on your own, popping it in just the way you see it, and you should end up with 62.354 for the volume here. Okay. Okay, so number 4 here is the same base. This time our cross sections are isosceles right triangles. So we're going to draw an isosceles right triangle this time. We'll see if I can get this with a right angle that's somewhat close up here. Okay, so this would be my right angle right here. And as we saw on the first page, we had a formula for an isosceles right triangle that was either 1/2 a squared, because these 2 sides are the same, so you could call these the base and the height. But then we also looked at this formula in terms of, what if we know this side here, b, what if we know the hypotenuse, okay? Which is what we know, because we know that this b value, this is our base, and our base has consistently been 2 times the square root of 9 minus x squared. Okay, so we know that b is, the base of this thing is 2 times the square root of 9 minus x squared. But the area of this thing, again, if we're going to use b for the area, our formula on the other page was b squared over 4. All right, so I need to take the integral, and I need to be careful on this because, again, we're going from negative 3 to 3, which is no big deal, same as the others. But I need b squared, which is my 2 times 9 minus x squared. And I need to square that portion and divide it by 4 and dx. All right, so again, I would use the calculator on this. I would encourage you to get out your calculator. If you pop this in, it's simply 36. It's just getting used to using the calculator on with the integrals. Okay? All right, our next one here, what do we have here? We have what is the volume of the solid with a base, same base, and now our perpendicular cross sections are circles. Let me see, cross sections perpendicular to the x-axis that are circles. Oh, this one's going to be interesting. Okay, so I'm going to have fun drawing this one. So we have a cross section now that is actually a full circle. So I'm going to draw a circle here as best as I can. This is going to, like I said, this is going to be interesting. So there's the top half of my circle. So I've got a circle and I'm cross-sectioning it with circles. If you look at the lower right-hand corner down here, you can see the same base with a cross-section of half circles right here. Okay, so what we're doing now is not just a half circle, we're doing a full circle. So my circle is not only going to come above, but it's also going to go down below like this. So those are my cross sections right there, if that makes sense. And this solid line going through the middle, that's my diameter of the circle, okay, which is also my upper minus my lower. Okay, so if I look at the formula for area of a circle is pi times the radius squared. Well, again, I know that the diameter is equal to 2 times the square root of 9 minus x squared, which tells me that the radius should equal half of that. Okay, so if you just divide that by 2, you get the square root of 9 minus x squared. And so there's my radius. And now I can do my integral. And so we're going to integrate from -3 to 3 of pi times the radius. So this is going to be times 9 minus x squared. And we're going to square that guy right there, and dx. Now again, this is one of those where you could do this, possibly part of it by hand. You'd actually do the whole thing by hand until you got down to the multiplication with pi. But again, just practice with your calculator. If you do this, it turns out to be 113.097. And remember, when we're taking these integrals, if you look at the shape again down in the lower right corner, that shape is not just a flat shape. It's got volume to it. So this is the volume of this thing. And if you put all of this together, this is actually a sphere. This shape would be a sphere with all these little circles. And you can see again down in the lower right corner, I've got a half sphere going over there. Okay? All right. Our next one here, the volume of the solid. This time we're using semicircles. So this time you can see that we're just doing semicircles right up on top here. So nothing down below. The only difference between the last one and this one is that we need to cut this in half. So our formula for area is going to be pi r squared divided by 2, which our radius doesn't change here. It's still 9 minus x squared, just like it was before. So our integral is going to be -3 to 3 of pi over 2 times the radius squared. So that's going to be the square root of 9 minus x squared and a dx. And that one is going to equal, oh, now this one here, looks like I did a little bit differently. You know, maybe we'll try and crank this one out by hand. So I'm going to do, let's see, this is going to be pi over 2 times the integral from -3 to 3 of 9 minus x squared dx. Taking an antiderivative, we would have pi halves. Let me see, times, what do we got here? 9x minus x cubed over 3. And we're going to go from -3 to 3 here. All right. So continuing on, here we go. We're going to get, what do we got? Pi halves. And then we're going to plug in 3. So that's going to be 9 times 3 minus 3 cubed over 3 minus, and then pi halves again. Pi halves times 9 times negative 3 minus negative 3 cubed over 3. All right, and we can probably finish this one up. This is going to be pi halves times, what do we got here? 27 minus 27 divided by 3 is 9 minus pi halves. This is going to be negative 27. This one's going to turn into plus because of all the negatives flying around in there. And that's going to be plus 9. And so we've got pi halves times 18 minus pi halves times negative 18 here. So that's going to turn to plus in the middle. So we've got 18 pi halves plus 18 pi halves, which is 36 pi halves. Is that right? So let me do this. This 18 times pi is 18 pi divided by 9. This would be 9 pi plus 9 pi, which is 18 pi. All right. And so, yep, I think that's right. And so there we go. So some of these you can easily crank out by hand, and again, we just wouldn't get decimal values in the final answer there. All right. There you go. Have fun.